Hello, welcome to the Senior High School Mathematics Forum. My name is Steven, and today we are going to look at rules of differentiation. Why do we have rules of differentiation? That became necessary because some functions were really difficult to be dealt with using the differential notation that arise to the rules of differentiation. So let's look at them. There are actually three in your syllabus, and I don't know, and onwards in other syllabus. But if some are there, I don't really know. So let's continue. And we are going to deal with them one after the other and then solve questions under each. So the first rule is the product rule. The product rule we have we have the product rule. We have the product rule. So this product rule, where do we use it? Where do we use it? How does it become necessary? And it becomes necessary, or we use it at a place where a particular function is equals to the product of as many as functions you can think of, like f of x is equals to v of x multiplying by g of x multiplying by u of x, in that order. This one the differential notation cannot be used. So what you will do is that you will have to use the product rule. So this continues to the number of functions you can have, and the product rule can be used there. So let's quickly look at how you can use the product rule. So having this and then using the product rule to differentiate this um will have it to be f f prime of x to be equal to, then you differentiate one function and maintain the rest. So we'll have v prime of x. The prime means differential. So let's take it that way. V prime of x, then multiplying by, that is dot, g of x dot u of x. That way you maintain the rest. Have you seen that if they were there, that's what you do? Then plus, you move on. You differentiate this one and maintain this and that. So we'll have v of x and multiplying by the differential of g of x, and then multiplying by u of x, and then you maintain the rest. So that's what we do. You maintain the rest. Now moving forward, you have plus we will have plus you differentiate this one and maintain the rest. So we'll have v of x dot g of x. So we differentiate u of x, so we'll have u prime of x multiplying by the rest. Have you seen that, guys? So if these functions were really there, like the dot 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 note telling us that it could be up to the number of functions we want. If they were really there, we'll continue that way throughout. So that is really the product rule. So now I have some questions here with me. We'll identify the questions that need the product rule and then go ahead to solve them. So here are the questions. So looking at these questions critically, we realize that the first question needs the product rule, and then the third question too needs the product rule. So we'll solve them very fast and move on because we don't want the video to be long. So now the first one says what? Says that f of x is equal to, then into bracket, 3x power 4 plus 2x plus 2, then multiplying by another bracket, x cube plus x plus 1. This denotes that it is a product of two functions. So let's quickly say this our function should be v of x, and this our function, this one should be u of x. This expression rather should be a function of u of x. This one should be v of x. So let's proceed to solve it. So in doing so, then we say solution. Solution. So we say f of x is equal to, bracket open, then we'll have 3x power 4 plus 2x plus 2, then bracket close, another bracket open, x cube plus x plus 1. This is what we will solve using the product rule. You know that, guys, if we were going to use the differential notation, we would have had to open the brackets by expanding and also go ahead to solve. So we can represent f of x as equal to v of x, as we denoted earlier on, times u of x. So our v of x will now be equal to 3x power 4 plus 2x plus 2. Have you seen that? And then u of x now will be equal to x cube plus x plus 1. Guys, have you seen that? So moving forward, we will have the differential of f of x to be f prime of x to be equal to v prime of x multiplying by u of x, then plus v of x multiplying by u prime of x. Have you seen that, guys? So this is what we should get using the product rule. So simple and easy to deal with rather. So we'll find their derivatives. That's the u of x and then v of x. So v of x, its derivative is v prime of x is equal to 12x, using the knowledge of differential, the differential notation. So 12x cube plus 2, and then u of x will now be equals to 3x squared plus 1. So we've obtained their differentials, and we can now substitute them into the function. The differential, the first, that is the product rule function. So the first differential function. So we'll have f prime of x to be equal to, then where is v prime of x? Here is it, guys. So put it there. 12x cube plus 2 multiplying by u of x. Where is it? So here is it, x cube plus x plus 1. Have you seen that, guys? Moving forward, we'll have it plus, where is v of x? Here is it. So we put v of x there, that is x cube plus x plus 1, then multiplying by u prime of x. This one is u prime of x. So that will be 3x squared plus 1 bracket close. So guys, as we've gotten here now, we can do our necessary simplifications. When we are to do so, we'll open all this. In doing so, we'll have 12x power 6 plus 12x power 4. This is power 6 power 4 plus 12x cube plus 2x cube plus 2x plus 2. Then we open this one too. So we have plus, then in opening that one we have 3x power 5, 3x power 5, then plus 3x cube, then plus 3x squared, then we have plus x cube, then we have plus x plus 1. So guys, I hope you know how to expand expressions already. So I will not, when they are multiplying by each other or one another, so I will not really go there. So this proceeding, we will get this, and then this is the only one with an exponent of, so put it there. Have 12x power 6. Then this one too is the only one, so put it there. 3 plus 3x power 5. Then we have plus, this is the only 4, so we have plus 12x power 4. Then we have how many 3's? 1, 2, 3, and 4. So we add all those ones. So we have here 14x cube, 17x cube, 18x cube. So we have it plus 18x cube. And then what? So from there we will have 3x squared to be next, and it is the only one. So plus 3x squared, and then from there we will have x here, x here. So 2x here and then x here rather. So we have 3x following, then plus 3. Have you seen that, guys? So this is our answer. This is really our answer. So guys, this is the answer to the question we were asked to solve, to differentiate. So let's move on to solve the next question. And here is the next question. I just want to solve it for you to know how to solve questions pertaining to product rule better. So let's move on. We have a lot to do. So now, here is the next question. The next question says that h of x is equal to h of x is equal to, in one bracket, 2x plus 1 multiplying by another bracket, 4x squared 4x squared plus x multiplying by another bracket 4x cube plus 3. So we identified this one as a function which also required the product rule. So we denote this as v of x, u of x, and this one p of x. So we now have it as h of x. We are just solving it like that, guys. So h of x is equal to the product of v of x, u of x, and p of x. So we have our v of x to be equal to 2x plus 1, and u of x to be equal to 4x squared plus x, and then p of x to be equals to 4x cube plus 3. Now the next thing is that we write down the product rule, that is the differential. So we have h prime of x to be equal to differentiate this and maintain the rest. V prime of x multiplying by u of x multiplying by p of x. Have you seen that, guys? Then then you maintain the two and differentiate the middle one. V of x multiplying by u prime of x multiplying by p of x. You do same to p plus v of x multiplying by u of x, then multiplying by p prime of x. So that's how we do it, guys. So meaning we are going to find the differential of this these three functions. So we have v prime of x using our differential notation knowledge to be 2, and then u prime of x will be equals to 8x plus 1, and then again p prime of x will be equal to 12x, so 12x squared rather. So this is our answers when we differentiate them. So now let's move on. Let's substitute everything into this particular equation. So we'll now have h prime of x to be equal to v prime of x, which is 2, times u of x, which is 4x squared plus x, times p of x, which is 4x cube plus 3, then plus u v of x, which is 2x plus 1, times u prime of x, which is 8x plus 1, then times p of x, which is 4x cube plus 3. So have you seen that, guys? Moving forward, so it will be plus v of x, which is 2x plus 1, that one times u of x, which is 4x squared plus x, and then that one multiplying by p prime of x, which is 12x squared. So this is it, guys. So we'll move on to expand all this, but in WAEC exam, they will not stress you that way. So we will have to expand this. When we expand that one, what will we get? So in expanding that one, we will get that will be 32x to the power 5 plus 24. 2 times 4 is what? 6. Sorry, 8 times 3, 24. Yeah, so 24x squared, then we'll have plus 8x power 4 plus 6x. So guys, we have expanded that one. Then let's move to this one. So we will have this one to be plus, then we expand this one and then multiply by this. So we'll have 16x squared plus 10x plus 1. Have you seen plus 1? Yeah. Have you seen that, guys? That one will be multiplying by 4x cube plus 2 plus 3 rather. Then that one plus when we multiply this by this, we'll get we get 24, we will get 24 x power 3. So sorry, let's just multiply it straight. So we'll have this times this to be 24 x power 3 times this to be 50 56. 24 times 4, 24 times 4, 24 times 4, 24 times 4 is not 56, it seems 96. 24 times 4, okay, it's 96. We'll have 96 x power 5, 96 x power 5, 96 x power 5, and then we'll have it plus 96 x power 5, 96 x power 5 plus, so let's move on. 96 x power 5 plus 12x squared times 4x squared. What will we get? We'll get 48x power 4. Get 48x power 4. Then we'll have 12x squared times x. What will we get? We will get 12x cube. Then we'll have 24x cube times x. What will we get? What will we get? So guys, we'll get 24x cube times x. We'll get 24x power 4. So moving forward, we'll have it to be equal to this and this are common. Have you seen that, guys? So these two and that are common, and both are common to this. So now we'll have 32 x power 5 plus 96 x power 5, which will be 100 and 128 x power 5. That one plus this, what will we get, guys? We'll get 72 x power 4 plus this 80 x power 4, 80 x power 4. Then we have keep here, we bring it, so plus 12x keep. Have you seen that, guys? So plus 12x keep, then we have squared here, plus 24x squared, then this is 6x, and then do we have any x here? No. So plus 6x. So this is it. So we now add it to the expansion of this. So plus in expanding this, we'll have 16 times 4, and 16 times 4 will be, that one will be 60 64 x power 5, and then that multiplying by this will be plus 40x power 4. This multiplying by this plus 40x, a 4x keep rather, then plus 3 multiplying by this, we will have 48x squared plus 30x plus 3. So have you seen that, guys? This is x power 5, this is x power 5, power 4, power 4, power 3, power 3, power 2, power 2, and then that way. So we quickly add them. So this will be 192x power 5 plus 120x power 4 plus 16x power 3 plus 72x power 2 plus 36x plus 3. So guys, this is our answer. So we move on to the next rule. So and the next rule is the chain rule. We have the next rule as the chain rule. So chain rule. We are done with the product rule. So we now go to chain rule. Okay. So where does it become necessary for us to use a chain rule? Okay. That is, I hope you've learned composition of functions. I hope you've learned compositions of functions. So it becomes necessary when we have composition of two, three, or more functions. Have you seen that? Such like we have composition of two, three functions like let's say g of x is the function which is equal to um p of f of u of, in that order. Have you seen that? So in that order, going p of f of u of, have you seen that? Until, so assuming it's a composition of three functions, we would have had rather g of x to be equal to p of f of u of x. This way, we would have had it this way. So guys, this is what I'm talking about. So when we have composition of functions like this, then we say um it is um it is it requires the chain rule. So let's move on. So let's move on. So I've explained. Now let's look at, so the chain rule having this, the chain rule is given by, when you are to differentiate, is given by g prime of x to be equals to p prime of f, p p prime of f multiplying by f prime of u multiplying by u prime of, continuing, u prime of the letter that will come, then dot 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 in that order. Have you seen that? U prime of the letter that will come, we don't know it, plus dot 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 dot. Have you seen that, guys? So this is what we do. Um this is how we use the chain rule. Then some people might be confused. Let me use this one to denote this so that you will not be confused. So we will have it as g prime of x is equals to p prime of f times that is of f of u, like that, or you can say of f times f prime of u times u prime of x. Have you seen that? So this is this one. Have you seen that? That's how we do that one. So guys, let's move on. Let's move on. So let's identify questions that need the chain rule. So here we see that this and um this and that need the chain rule. Let me actually bring out that question. So this is the question that I talked about. I've marked this. They need a chain rule. So let's move on. Let's solve this first. So in solving that one, what will we get, guys? Let's move on. So we have it as g of x. G of x is equal to into bracket x power 5 plus x plus 1 all bracket close power 7. So this can be rewritten as g of x. Let's say this is p of x. So this can be rewritten as g of x is equals to, let's say, q of p of x. Have you seen that, guys? Q of p of x. Have you seen that, guys? So where where p of x is equal to power 5 x power 5 plus x plus 1, and then q of p of x is equal to, that one is equal to um that one is equal to q of p of x power 7. Have you seen that, guys? So now we are finding their primes. So p prime of x is equal to p prime of x is equal to 5x power 4 plus 1, and then q prime of p of x is equal to 7 multiplying by p of x power 6. So have you seen that, guys? This is how we go about it. So now putting everything into this, into g prime of x is equal to q prime of p multiplying by p prime of x, putting everything into g prime of x multiplying by q prime of p, q prime of p multiplying by p prime of x. We will have it equal to, where's q prime of p? This is it. 7 multiplying by let's use p instead of p of x, p power 6. Have you seen that, guys? So we'll have it plus then we'll have it times this 5x power 4 plus 1. So this is it, guys. Then you know your p of x. What was the p of x? P of x was equal to this. Then you now substitute the p of x there. We will have it as 7 multiplying by 5x power 4 plus 1, then multiplying by x power 5 plus x plus 1, all power 6. So this is our differential. I'm using the chain rule. So let's move on. The question we identified, this one. So this one actually is confusing, and I just intentionally brought it to clarify your mind, make you think well. So let's move on to solve that question. So when we have a question like this, you see that it is confusing, but we can solve it. So we say the whole of this should be q of x. Have you seen that? And then this you see that they are common. This should be let's leave that one aside. Let's say the whole of this should be let's say, not the whole, actually the whole of this. There are some functions inside there, but let's just denote them that way. So it's equals to f of x. So and then we have minus 1 here, and then we have it. So actually, let me go on to do the right thing so that you see. It will actually be this way. P of x, it is equal to q of what? Q of f of u of x. Have you seen that? This is the composition that I was talking about. So to avoid confusing you, let me just go straight forward to tell you how it is. So now this is really it. Have you seen that? Whereby you say, how? So where u of x is equal to x squared plus x. Have you seen that? And then f of u of x, have you seen that, is equal to, let's denote the u for the u of x, u power 4 plus u minus 1. Have you seen that, guys? And we have q of f of u of x. So let's just denote them. Let's just denote the f of u. Let's just denote f of u of x as f of u. So we'll have it equals to f of u all power 3. So this is how it is. So this is how it is, guys. So let's move on. So in solving that one, we will have it as p prime of x, p prime of x to be equal to q prime of f of what? F of what? U of what? X. Have you seen that, guys? Let me rewrite it. Q prime of what? F of u of x. This is it. Multiplying by f prime of u of x, multiplying by u prime of x. Have you seen that, guys? So this is how it is. Then u prime of x is what? U prime of x is equal to what? So u prime of x will be equal to 2x plus 1, and then f prime of u of x will be equal to what? That one will be equal to 4x, sorry, 4u rather, 4u power 3 plus 1. Have you seen that, guys? So this is how it will be. And then we have q prime of f of u f of u f of u of x, f of u of x. That one will be equal to 3fu power 3fu power 3fu power 3 power 2 rather, guys. So this is how, this is it. So now, guys, what we will do is that so what we will do is that we now multiply them. We will have, in multiplying them, we will have p prime of x to be equal to 3 times what? 3 times f of u of what? F of u of x squared times times this one, and that will be what? 4u keep plus 1 then times 2x plus 1. Have you seen that, guys? So what was our u? Our u was this. U of x was this. Have you seen that, guys? So we can quickly write it as equal to um as equal to 3 multiplying by, we substitute the u there, so multiplying by 2x plus 1, multiplying by substituting the u there, we'll have 4, then we'll have bracket open, substituting the u there. What was the u? 2x plus 1, sorry, the u was x squared plus x. So substituting the u there, we'll have x squared plus x, bracket close, then that one plus 1. Have you seen that, guys? This is actually the thing. So that one plus 1, square bracket close, this should be square bracket. Then multiplying by the whole of this, f of u of x squared. I brought a 3 here. So f of u of x squared. What is f of u of x? So f of u of x is the whole of this. Have you seen that? That's f of u of x. F of u of x is the whole of this. So that one squared. So we'll now have it multiplying by square bracket open, square bracket open, square bracket open. Then we'll have x squared plus x, bracket close, power 4, plus bracket open, x squared plus x, bracket close, minus 1, then square bracket close, power 2. So guys, we have differentiated it like that. We have differentiated it like that. So we have differentiated the whole thing like that. So it will be 3 times 2x plus 1, then multiply by 4 square bracket open, 4 multiplying by another bracket open, x squared plus x, bracket close, plus 1, then multiplying by square bracket open, x squared, bracket open, x squared plus x all power 4, plus another bracket open, x squared plus x minus 1. So guys, if you want, you can expand this one. You can expand this. If you want, you can expand this. Okay? You can simplify this rather. That's expand, yeah. So thank you. This is our answer. So this is our answer to the question. So let's move on. The last one is the quotient rule. So let's really deal with the quotient rule. So quotient rule. Quotient rule. So what does it say? The quotient rule says that when you have a rational function, you use that one. So that is a function f of x is equals to g of x all over h of x, requires the quotient rule, whereby let's see, whereby h of x is not equal to 0. Have you seen that? So this requires the quotient rule. This requires the quotient rule. So the quotient rule is now stated as this, meaning f prime of x, the differential of f of x, will be equal to h of x multiplying by g prime of x minus h prime of x multiplying by g of x, this all over h of x, that one squared. Have you seen that, guys? So that is how it is. That is how we do that one. So looking at these questions, which one requires the quotient rule? So this requires the quotient rule, and which one again? This requires the quotient rule. But this is a combination of all. A combination of all. So let's move on to solve the one that requires the quotient rule. So let's solve this first. So we have it as we have it as g of x is equal to x squared plus 2x all over x squared plus all over x squared minus 4. Have you seen that, guys? All over x squared minus 4. So this is it. So what we will do is I will say v of x is equal to x squared plus 2x, and then u of x is equal to x squared minus 4. So now we find their derivatives, their differential, because g prime of x will be equal to will really be equal to u of x multiplying by v prime of x minus u prime of x multiplying by v of x all over u of x, that one squared. Have you seen that, guys? It will be this way. So now what we will do is that we find the primes of this. So v prime of x will be equals to 2x plus 2, and then u prime of x will be equals to 2x. So guys, have you seen that? We quickly substitute them here. So if we are substituting, we will have g prime of x to be equal to u prime u of x, that is v of x rather. Sorry, u of x, that is the one below. U of x, which is x squared minus 4 multiplying by v prime of x, which is equal to 2x plus 2, that one minus u prime of x, which is 2x multiplying by v of x, which is x squared plus 2x, that one all over u of x, which is x squared minus 4 all squared. So guys, this is what we've had. Then moving forward, what will we get? We'll have g prime of x to be equal to, expanding this, we will have it to be equal to x 2x power 3 plus 2x squared minus 8x minus 8, that one minus 2x power 3. Have you seen that, guys? So minus 4x squared. So all over bracket open x squared minus 4 all squared. So g prime of x will now be equal to, this will go away with that, then we'll have this minus this, leaving minus 2x. So we'll have minus 2x squared minus 8x minus 8. So have you seen that, guys? All over. So we'll have x squared minus 4, that squared. Have you seen that, guys? So you can really do some factorization if they are there. So this one will be equal to we'll have it as um we'll have it as so we'll have it as um we'll have this as minus 2 out, x squared minus plus 4 rather, x plus 4 all over. So you can factorize rather. So all over, then we'll have it as this way: x squared minus 4 all squared. Guys, have you seen that? Always be creative. Always think, so that you will not earn your answer at a place where you will not get the full marks. Have you seen that? So in factorizing this one, we will get this times this is 4. 2 plus 2 will give you 4. So we'll have it as 2 times x plus 2 plus times another x plus 2. Guys, have you seen that? This will be all over. Then this one, we can have it as x squared minus 4 in bracket, one bracket, x squared minus 4 in another bracket. Have you seen that, guys? So this will actually give us minus 2 multiplying by x plus 2 multiplying by another x plus 2, then all over difference of two squares here. So x minus 2, x plus 2, x minus 2, x plus 2. Have you seen that, guys? So this x plus 2 will go with this x plus 2 will go with this. So our final, these are same, so you can square them. So our final answer will now be equal to minus 2 all over x minus 2 squared. So this is our answer. So now moving forward, this one, so far as we've solved this one, that means that you can solve this one, and then this one needs the combination of all the rules, the product, the quotient, and and yeah, the product, the chain rule, and the quotient. So that is it. So that really comes when you are differentiating this particular numerator. You use the product and then the chain rule at the same time simultaneously. Have you seen that, guys? And then this one, it doesn't need any of the rules. You can use your this thing to differentiate it. So that is it. So I give it to you as an assignment. Can really solve it, but the video is becoming too large, the duration. So thank you. Please subscribe and like, share, turn on the notification bell for more videos. Thank you.